So, hi, my name is Rene Rideau, and I'm a freelance developer working for the Tunes project here, which is a project to reinvent computing. And today I'm going to tell you about creationism and evolutionism for computing. I was once asked to explain what Tunes was about, and then I say, it's about evolutionary computing. And then people ask me, well, if that's evolutionary, then what is creationism for computing? And then I started, and so this talk was accepted at the Salon des Refusés in April, and I haven't rehearsed it since April, so we'll see what gives. Okay, so this is a short introduction, no rondo capriccioso for you, and this is my cheat sheet. Okay, and so who here likes stories? Stories. Okay, who doesn't like stories? You suck. Well, still there are stories. I have another talk about stories on Saturday, so maybe you won't like my talk on Saturday. So what are the most thrilling stories? Like when you have a hero, what you want to know most about this hero? When they show you a Superman movie or the Spider-Man movie, what do they show first? The origins. The origin story is the most important story for the hero. It's so important that after you tell a few stories and the ratings go down, what do? You do a reboot. You tell a new Spider-Man or whatever story or Star Trek, whatever it is. Okay, so that's how good origin stories are. And what's the greatest of all origin stories? No? The origin of the world. Okay? Also known as cosmogony. Cosmogony means the origin of the generation of the cosmos, of the universe. Okay, and associated to every cosmogony there is what we call a theodicy. So who here knows philosophy or Greek and can tell me what theodicy is? Okay, theodicy in Greek means the trial of God. God is put on trial. Why? Because there is evil in the world. Why is there evil in the world? That's the trial of God. But, of course, I'm not going to tell you about theogony and theodicy because this is a computer science conference, and I don't have much to add to this debate, so that's not what you paid good money to hear. So I'm here to tell you about logogony and anthropodicy. And don't look for it in a dictionary because I made up these words recently. So maybe if you Google them, you'll find my pages. So what is a logogony? Logogony is the story of the origins of software, logic, logos, logiciel we say in French. So a story of origins of software. And to every logogony, of course, it will be associated an anthropodicy, the trial of man. Explain why there are defects in software, why software is not perfect, the trial of man. Okay, and as you see, my stories are not about God creating man. That's off limit. I'm not talking about that. I'm going to make analogies, but it's not about God creating man. It's about man creating software. So, and to illustrate that, I will make the analogies, but I will also argue that it's not always analogical. And for that, if you ask the question, does man exist? I think there's much less controversy on this question than the question, does God exist? So maybe the machines will someday ask whether man exists, but I think we can give them a definite answer. Okay, so without further ado, here's the first and simplest logogony. What is the simplest logogony you can think of? Why does software exist? Software exists because more directly. How did the software appear? What made the software appear?
Someone wrote it.
Someone wrote it, exactly. Man wrote it, or woman, because the first programmer was a woman. That's a logogony. And the simplest of all logogonies I call instant creationism. Like you say, let the software be, and the software was. Okay? And don't laugh too much, because that's how lay people think that software appears. Like, the software exists because someone wrote it, And it's also the paradigm that's taught in school. When at school you're told, write a 5-line program that does this. Or someone can have gone out of school and not have seen any other kind of software, logogonies and instant creationism. Like, please write the 10-line program that does this. You write it, you have an A, you fail, you have an F, and goodbye, see you next semester. So, when we have the instant creationism, which therefore perfectly describes a lot of small programs and one-liners that you write, what tools do you need when you have this kind of logogony? You don't need any tool. All you need is pen and paper. And Dijkstra would be proud, because Dijkstra says that's how you should write software. You should write using pen and paper, and when it's perfect, it works. And of course, there are like some small details, like you need like a switchboard or something to enter the software into the machine. But that's for the small hands who do that. Like the real programmer uses pen and paper. And so, what is the simplest anthropodicy now? Why do software defects exist? Can someone give me the simplest theories I can come up with? Maybe, yes?
Because they wrote it wrong.
Yes, but how do we call the defects?
The world is fallen.
What's the common name for a software defect? A bug! A bug. The software, there are defects because there are bugs. And what is a bug? A bug is a monster. It's something from the outside. It's something sent by the devil to make your software not work. And that's why we have like bug. We have plenty of. We think of bugs as something outside from us that comes invade our programs. And so when we have all those bugs, what we do? And once again, the devil, of course, is a metaphor. It can be the loyal or the disloyal opposition to the perfect programmer God, and it can be a separate entity. It can be a second personality of God, maybe, or it can be the absence of God. That doesn't matter at this point. What matters is that there's an evil force. And so to fight the devil, what do you need? There you need real tools like punch cards or Blicken lights or additive states to fix the punch cards. And this way you can triple check that what your programmer gods want is indeed what is gets into the computer without any tampering by the devil. And we also have the first programming language, which is assembler, because when you change a statement, you don't want to have to recompute all the addresses and all the offsets. So that's how the first programming language was invented, which is assembler and not Fortran. And that leads to the main point, which is with better stories, you have better tools. Without story, when you didn't have story, when the programs were just perfect, you didn't need any tool. But now that you have a story that there's an opposition, now you have tools that correspond to the opposition you have. And when you better understand the opposition, you get better tools. So, but also the devil mixing is, with any story that I'm going to tell you, we can add the devil in the story, and it will make the story more interesting. Like in every story, if there's no opposition to the hero, okay. But if there's opposition, then the story becomes like interesting. You can always spice up the story like that. And that's also a first meta tool, like a way to spice up stories. So we can see that there are limits to instant creationism, because we find that programs are not born all equipped and unbugged and all armed, all featured from the head of the master programmer. That doesn't usually happen. And so we have our second simplest logogony, which I called layer creation. So on first day, man separates the requirements for the bugs, and then he divides the program into routine, etc., etc. And on day 7, he rests and he runs the demo and it runs flawlessly. And that's what I call layer creation. Or we also, so what does it lead? It leads to flowcharts, things like that. The modern version of flowcharts, of course, being UML, that you may all love. We have also the waterfall process that derives from this. First we do this, and in the end it just works. Like we have divide and conquer algorithms, where we have to divide the problem into smaller problems. And of course, in terms of programming language, we have Fortran. So Fortran is kind of a layer on top of assembly that abstracts things away. And unhappily, the devil is at work at each step of our nice waterfall process. So what happens? We have layered creation with a devel. So we have our waterfall process, and then we have, at the end, it still doesn't work, so we iterate, and at every time we iterate. And what does this iteration of creation correspond to? I think it has a name. So, of course, we have like releases, etc., but we have even fossils, because at every layer we have like software artifacts from previous layers of creations. And we have backward compatibility and path dependence. And so there is a name for this logogony. What's the proper name for the logogony of this kind of iterated creation where you have fossils, where you have, do you have the name for it? I call it intelligent design. And here again, it's Dijkstra. And intelligent design is a logogony in which man cannot create the software in one act because it's too big, and it's the devel is there, and we must find the devel. So instead, we have many steps, and you start from the foundations, you build layers, and more layers, you bootstrap complex data structures, you have tools and tool-making infrastructures, and you build scaffolding, but it all goes according to the master plan. And this logogony is very popular among software professionals, actually. And why is it so popular, and why in our resumes and why in our recruiting, when we get recruited, we always put forward this? Because it's an ego boost. We call ourselves software engineers or things like that, because we like to feel like we're in control, we're intelligent, and we can deal with larger. So we have to deal. We understand that there's a devel we have to fight, but that makes us more intelligent than the beginners who are only stuck with instant creationism. We can do more, but we're still intelligent. So we understand that we're not perfect, but we're still the master around here, and that's the ego boost. It's flattering. And with this logogony, we have plenty of tools. We have structured programming, we have algebraic data structures, we have all kinds of plumbing, programming infrastructure. You have operating system, compilers, compilers, build systems, modeling tools, all kinds of hierarchically designed systems, and this iterated waterfall process and release cycles. And these are all great tools to have. And so, once again, with a better story, we get better tools. And that's time now for our next story mix-in, which is polytheism. The fact that, indeed, when you write software, and it's big enough, you need many gods, many programmers to write the software. And so everyone does part. This is the first Fortran team, by the way. Everyone does part of the system. You have even this Conway's law. If you have like 1, 2, 3, 4, 5, 6, 7, if you have 7 people in your compiler team, there will be 7 passes to your compiler, and things like that. So, and once again, it could be. So it could be called polyanthropism instead of polytheism, since it's, in this case, men instead of gods. But the idea is still that you can't write the software with one brain. Even if it's one brain, you have to reconfigure your brain between 2 passes and between writing different parts of your software. So you need to deal with multiple gods. So you need now tools. What kind of tools do you need? You need files and directories so they can separate the work. You need time sharing on your Unix or whatever box, or you need comments and documentation. Before you didn't need comments because you were only talking to yourself. Now you need comments because you're talking to other programmers or your future self, and documentation. You need communication protocols. And of course you can combine polytheism with the devel mixin, and then you have like the titanomachy, where you have like opposite teams, or just stupid people in your team, or evil like rivals in your team, or in other team, or the Russian hacker, something like that. So you have a clash between programmers, and that makes things like Emacs and VI. No, Emacs, like VI are the bad guys. And it could be, once again, a split personality or a bad tendency or a personality disorder, but there is this notion that some programmers are good, or at least with you, and some programmers are not with you. And then what do you need? You need access control. You need code review. You need backups. You need cryptography. You need errata to your documentation. And you need pages intentionally left blank to have space for these errata. And so after we factor all this code out, so that's already lots and lots of additional and new tools. And yet, even with all these new tools, we find that there are still bugs. Like, even the best development teams reach their limits. And not only do we introduce bugs, but sometimes we pursue like totally nonsensical goals. Why do you even try to write this thing? Like, it doesn't even make sense. Sometimes the methods we pursue are totally absurd. It's not like we introduce a bug. It's like the bug is at so high level that like this code, like you should have just thought before you try to write that code. It's not just bugs. It's that in the end, we have unintelligent design. Like, we have to recognize that as far as gods go, we programmers suck. You know? And there's a very nice page, unintelligent design, that you may want to look. It's very funny. But yeah, most programmers have no idea what they're doing. And so, in as much as we're rational, and I suppose we're not totally irrational, but we have bounded rationality, to put it mildly. So, rationality is a scarce resource, and we must use it well and allocate it well. And that depresses the programmer's ego, but that leads to new tools. So, we have prosthetic devices. So, what kind of tools do we have? We have meaningful error messages, not just error line 10, but something that tries to explain you how stupid you are and what you should have done better. You have syntax checkers, you have highlighters, you have formatters, you have interactive editors, you have types that are an error finding and error correcting mechanism, as well as a design guide. You have interactive help and manual because you're so stupid you couldn't remember those simple things. And you have development environments. If you add polytheism, you have to divide code into modules small enough to fit into a very small brain. And you must make sure that the interface to your code is itself much smaller than the content of your code, otherwise it will not contribute to decreasing the pressure on brain size. So with Devil, you had the testing, you had contracts, you have tripwires and security through obscurity. You have, but happily, most of the devils are just as idiotic as you are. So that's the good news. So these are all essential tools, but unhappily, in the end, they are never sufficient. You try to make your software more idiot-proof, and yet the programmers are even more idiotic than you thought. So first, we can pause and find that, yes, indeed, better tools come from humility. Every story brings better tools. And why they bring better tools? Because we recognize our deficiencies. It's by being humble, by recognizing I don't have an infinite brain. I don't write perfect code. I can't even remember the manual. I can't type check in my head, you know? By all this recognitions of your deficiencies, all this humility is what brings better tools. If you don't recognize that your eyesight sucks, you will never wear glasses. Oh, I see perfectly your face. I mean, you're blurry, that's how you are. So it's humility that gives better tools. And one of the limitations, of course, I'm addressing is hypocrisy. Remember how we show ourselves in our resumes as software engineers, but yet we do use the tools of an intelligent design. So even what we say is that we're software engineers, but implicitly the way we behave is we recognize that we're unintelligent. But we recognize it not openly. And because we don't recognize it openly, we don't get the full benefits of the prosthetic devices because we fail to recognize fully how much help we need. So if anything, if you recognize, if this talk helps you reflect more on your failures and your limitations and how you can address them, this will already be useful. But how far do we have to humiliate ourselves before we find the correct story, or at least a good story for how software happens? Well, before I can go further and in the humiliation, we have to notice a pattern. And this pattern, we have to change point of view. And the new point of view is what I call Lamarckism. Lamarckism, at its core, it does not offer any explanation on how software comes about, but it changes the point of view from the state of the software to the changes that happen to the state of the software. So instead of looking, oh, the software is at version 0s and 1s and 2, look, oh, what are the changes that happen between all these things? And you look, oh, it's interesting, and it leads to a lot of new tools. For instance, the tool from Lamarckism or version control. We can deal with multiple versions. We have diff, we have patch, and then we can look, and then when we audit the code, for instance, we don't have to audit the whole code. We can only audit the diffs. Well, most of the time that's sufficient, but not always. But at least it gives us a mechanism to track better what changes and what we need to focus on. We have, with polytheism, we have distributed version control, things like Git. And with the devil mixin, we have code reviews from pull requests. You'll want to audit the pull requests. So even without telling us how software comes about, already Lamarckism brings new tools. It also tells us about incrementality. Now you have incremental build, you have functional reactive programming, you have code differentiation, you have data structure derivatives, you have feature planning and security patches. You think in terms of incrementality. And once you start thinking about changes and why some changes work and why some changes don't, you enter into the realm of evolutionism. So obviously, as men write changes, some are better than the others, and some are worse. Better and worse have to be defined somehow. And somehow, the better ones survive, and somehow, the worse ones don't. And this naive theory of evolution is called supernatural selection. The supernatural selection is the idea that there is a superior God, that in this case a programmer, who looks at the changes and says, oh, this change is good and this change is bad, and I'll pick this one because it's good. And so God understands and runs perfectly the fitness function, basically, of your patches. And this brings immediately new tools. So tool from supernatural selection, this is Norbert Wiener from MIT. You can have, for instance, formal specifications that describe the perfect goal, like the perfect fitness function, and then you just have to use a heuristic search to find a solution to this problem. So search is an obvious thing. Declarative programming, where you specify what you want to compute, the fitness function, and you let the computer figure out how to get it. And so you get meta-programming. Organizationally, you can do prototyping to make more mistakes faster, so you can have a faster loop. You can have developer communities to spread the good code and ideas, and it identifies the bad code. You can have conferences like this one. You can have journals. In terms of security, you can have scanning. And in terms of ideas, all this has been summarized as an idea of the first wave of cybernetics. But of course, soon enough, programmers find that in general, they're still not intelligent enough to design a fitness function. So our next logogony is teleological evolution. Teleological evolution is the theory where the programmer is unintelligent also as far as the fitness function goes. We have like very limited intelligence. We can write fitness functions, but we're not that great at them. It's so our knowledge is partial. We have to rely on intuition and luck on the path to progress. And so we have better tools. So what kind of tools do we have? We have genetic algorithms. We have supervised learning and neural networks. We have probabilistically approximately correct learning methods. We have weakly structured computation. We have data mining from large database. We have randomized algorithms. We have the fact that we accept that security is an arms race rather than just a single fight. We have probabilistic proofs rather than formal proofs. We have organizationally aiming for good enough rather than perfect. We have user communities and not just developer communities. We have reliance on distributed knowledge because we are imperfect and we have to stand with each other. But this is still not humble enough. Because we still think there that, okay, we're not perfect, but we're still in control. We're not in control directly of the code, but we're in control of the goals. And that's still not humble enough. Because we have to recognize that software development is bigger than that. It's bigger than human cognition. It's bigger than our power to define where we're going to go next. We have to abandon this faith in the ultimate power of human reason and collective action and recognize that man's conscious intent is not what drives the evolution of software in the end. And when we let go of all these pretensions of the man being the god above, what do we have? We have actual software Darwinism, or how I like to call it, natural selection. Not supernatural selection, but natural selection. So natural selection is a statement that is a tautological statement that whatever software survives, survives, and whatever software does not survive, does not survive. And a tautology, of course, is a statement that is tautological. So the survival of the fittest is its own tautological criterion. It's not it's better for man. It's not it's better because like man God knows it's better. It's just it's better because it survives, and survives defines its own criterion of being better. So there is no value attachment to survival. You don't survive because you're prettiest or anything. You survive because you survive. There is no scientific adherence to anything but survival itself. But still, statistically, if some classes of chances improve their own odds at surviving and propagating than others, then they will tend to survive and propagate more than others in the niche in which they have the statistical property. And conversely, if some changes have a statistical tendency to impact their own propagation and their own survival negatively, then they will tend to disappear from this niche and be replaced by other changes. So it's contextual, but it's statistical. It's not exact, but still we can find explanations, and then we understand that changes favor themselves. It could be that some changes are viruses, and that they do not benefit any man, neither the users nor the developers, but they still propagate. I'm sure you can think of a few programming languages that you would personally consider as viruses that you wouldn't want to touch. And it's not just programming language. It can be operating systems. It can be the editors that the other guys use. It can be anything. Like there's plenty of software that survives despite the interest of the developer or the users or anyone, just for their own interest. So there is no magic adequacy of the software for man. The software is adequate for itself. And then when you understand that software can be parasitic and that man is not in control, or not always, or not, it's not ultimately in control, then you understand that man is but a pawn in the evolution of software. You're not the master, you're the pawn. You're not the king. You're not even the player. You're just a pawn. And this freewheeling software evolution makes a mockery of manly intervention. You think you're intervening, but no, you're just part of the things being selected for or against. Or you get a job, you do the job, or you stop writing programs, or you keep writing programs because you do something right or wrong. And it doesn't have to be right or wrong according to any specific theory of morality, just right or wrong according to its own survival, its own success. So man is not an entity above software. Man is just another bundle of self-reproducing software traits competing to exploit the limited resources in the universe. And certainly, as compared to other bundles of self-reproducing software traits, men are unique and different. I mean, of course you're unique and different. Everyone is unique and different. This is a scene from Life of Brian. You're all individuals. They say, yes, we're all individuals. And there's an idiot who says, no, I'm not. So what tools do we have from software, from natural selection? We have the fact that in this robot world, we have to fight, and you have to do whatever the hell it takes for you to survive, or you don't, and then you don't. And you will be replaced and forgotten. So this takes us back to the question we had, like, does man exist? Yes, duh, of course man exists. I think no one here will discuss that, but the answer is also that man is not God. The robot will not ask whether man exists. He will still ask whether God exists, and he will still be as befuddled by this question or not befuddled by this question, depending on how you ask it. But yes, man is not analogous to God. Man is analogous to another machine in the system. We don't write, God does not care for whatever software you write. Maybe God writes software, but he writes software in his language on his machine. He doesn't care what programs you write, and he doesn't give a damn about it. And his software does not run on any of man's computers. So for him, any evolution from human software is spectator sport at best. If he looks at it, maybe he looks but he doesn't touch, he won't change the bits in your software to make it work. So in as much as some men think they are gods and think they are either like intelligent or intelligent, they are wrong. Man is not a god. And he's just a competitor among others in this world. And that is real software Darwinism. And that's what I really mean when I say evolution. But there are some upsides to understanding that. What are Darwinistic tools? We have things like artificial life. We have things like unsupervised learning from competing survival models and from the competitive survival of models. So you make models of Go players fight against each other, and in the end you have AlphaGo, for instance. So that's the third wave of cybernetics, and it does have applications already, like AlphaGo indeed. In security, you understand that the opposing forces are natural and human, and they are subject to learning and retaliation, and networks are friends. So you understand that security is social and not just technical and things like that. And mostly Darwinism brings us Darwinistic metatools, which is like a better understanding of the world, a better wisdom, a new perspective on software survival and our survival, and it makes us more skeptical of fads because now we understand that we cannot buy software at face value. We must study whether it's a parasite or it's going to help us or things like that, whether it can be a symbiont or whether it's really inimical. We have a better models and heuristics to decide what software to accept or reject. We can then avoid wasting time on evolutionarily unstable organizations and unstable software and try to focus our time on things that will last or that will achieve our purposes or that at least are not obviously wrong once you understand how the world works. So then you will try to devise small tweaks that have large effects on the way they change the evolutionary equilibrium. That's what is more useful. You understand like systemantics, which is a theory that large systems are all born small and grow in a way that at every step they keep working. You don't have any large system that pops up out of existence like this. You can relate to the spread of ideas to demographics. You know, like paradigm changes. The paradigms change when the population changes. So you can relate memetics to genetics and understand the fork and merges of traditions. And you understand that the hardware, the software, and the wetware live in fragile ecosystems that you need to take care of. And you understand that software changes compete on a market driven by economic cost and benefit and not just by technical cost and benefit. As technicians, we're often too focused on the technical cost and benefits and not enough on the economic cost and benefits. And so all this change in point of view help us use our limited resources better because we understand what we're against. And yet, most of my conclusions here have been mostly negative and depressing. It's like, oh, you're a downer, like, but Darwinism reminds us that there is no silver bullet, no magic way to win always and enjoy life and be lazy, because whenever you find something that makes you win against everyone, well, everyone will copy you and then you're just at the same place as everyone else again. So it's an arms race. You can't stop. You have to go forward all the time. But you can see where the others fail to go forward and still take advantage of this. But yes, this understanding removes the wool from our eyes. We can dispel the illusions and see through fake solutions. And then we can understand that there are no magic authorities. No expert you can blindly follow. Even they are right today, they will be wrong tomorrow. Or you have to be your own judge. And life will be your own ultimate judge. It will decide whether you succeed or fail, and there's no substitute. So don't follow anyone, don't follow me, certainly. And yes, Darwinism is a huge downer, and some people will say that it brings a soulless marketplace, but there is a soul in that marketplace, and the soul is, it's you! Because evolution is an inside job. Once again, you are not a god watching evolution from the outside and telling, oh, it sucks. No, you're not a spectator god. You're inside. You're one of the animals inside. And there is a soul. And sure, you don't have access to God's soul, but you have access to your own soul. You can make the software work, you can make the evolution happen, and you decide what happened. And if your values do not correspond to the values of the world, you can say fuck you to the world. You don't have to follow. If you don't like survival, well, you don't have to. You do whatever you want. You're the soul. You're not the God, but you're better than the God. You're you. You're an actor. You're something. You're in the world. You're an earthworm, but you're a good earthworm. You've been to that talk. You understand these things now, or maybe you already did before. So it's a positive message. You don't let nature decide. You are part of the nature that decides. And whichever genes or memes you carry, you choose which you want to fight for. Maybe I don't like the fact that I'm half blind. Maybe I don't care to propagate that gene or that meme, but there are other genes and memes I care to propagate, and I choose which, and I will fight for them. And so you're either in the experimental set of the changes that may or may not work out well, or you're in the control set of the changes that don't change and that will certainly be replaced someday. So you choose what you fight for, and only you can do that. So what are the tools for the evolution insider? Well, the fact that you understand that you have limited resources and now you have to invest them wisely. You understand the difference between consumption and investment, between asset and liability. You understand that you must seize opportunities and understand opportunity cost. That is economics 101. And ultimately, the ultimate resource exclusive that you possess is yourself and your own time. So you must invest in yourself. Organizationally, you must understand that division of labor and specialization of tasks is how you can be more productive. You must seek the most win-win games, the interactions that are mutually beneficial rather than win-lose or lose-lose. You must develop cooperation tools that are social as well as technical, like go to conferences like this and find friends and who can collaborate with you. You understand that incentives matter and not just information. You must make people work together rather than against each other. And you understand that organizations and contracts must have good incentive structure. You understand that security is also learning how to recognize the parasites and how to avoid them. You understand that you are the entrepreneur of your own life, and that's why this is USS NCC Enterprise. Life is an enterprise. Come on, and you have to embrace your responsibility for your own soul, and the universe is not soulless anymore. And to conclude, stories evolve. I showed you an evolution of plenty of stories from instead creationism to this Darwinistic view. Better tools come from more humility. Recognizing your deficiencies is how you can address them. A tautology is a tautology, and the soul is you. And that ends at least the formal part of my talk. And thank you for listening, and I hope you enjoyed it. Any questions? No question. Okay. So you understand the universe. You think that this is the ultimate story? Yes.
Yeah. So I read a little bit of your website and stuff, and it
yes.
looks like you're personally interested in building some big changes to how we use software, like
yes.
maybe the Tunes project and stuff.
Yes.
Can you talk some about how these ideas affected your strategy for that?
Okay, so in case the microphone did not record that, how are these ideas related to the big changes I want to make in the world of software? Well, I started the Tunes project when I was at school, like 20 odd years ago. I'm ashamed I still didn't make it happen. But yes, the two are related. Once again, this talk started from a friend asking me, what is the essence of the Tunes project? And I told him, well, it's about like dynamic thinking, like thinking in an evolutionary way, rather than a creationist way. And then it led me to this series of stories. But yes, I think that most people are locked in bad stories and don't see past. And even if they act past unconsciously, consciously they're still locked in the bad stories that tremendously limit what they can do. I think, for instance, that software is going to change a lot, of course. So there are theories that say, oh, software is already topped. Like we already know everything we know about software, so it's not going to evolve much. Or you can say, so that presentism, if you want. Or you can say, oh, actually, it's going to grow a lot. Well, at some point, we will have a good enough theory of software, such that a better theory would be too complex to fit in our brain or whatever. So, but we probably haven't reached that point yet. And I think there are things like the fact that you should understand that interaction with a computer is not a command and control interaction. It is an interaction. When I program, I don't tell the computer, hey, I know exactly what I want. I start asking a question, it replies. I ask a question, it replies. And of course, we have very different proficiencies, the computer and I. It's very good at making very computation. It's very fast without a mistake, but it's very bad at other things. That for now, it's bad at figuring out where we want to go, etc. So it's a dialogue. Once you understand that programming is a dialogue, you change your approach to software. It's not, you don't want a command and control loop. You want an interactive system. You want to be able maybe teach the software, the computer how to write by example, and then refine the example until the software has a good understanding. So you want, but it's not there are people who say, oh, let's program by example, just show the example, and that's good. That's good. No, that's not what I mean. You want to write an example and see what the computer understands as a general thing, and then refine that understanding based on example or things like it. It's not just examples. It is an interaction. Like I'm showing you something, and then I'm testing what you believe it is. Like just when you teach language to a kid, you show something, but then you verify, and if the kid didn't get exactly what you mean, you refine. And yes, just this interactive thing is big in my Tunes project, etc. I want people to understand. Yes, to think in terms of processes rather than products, think in dynamic terms rather than static terms. And I have a talk about that on Saturday, so yes. Other question?
So there's this thing Google published recently where they're using neural networks to evolve or discover better neural network topologies.
Yes.
Does that kind of like non-human evolution fit into this framework?
Yes, sooner or later, I suppose that humans will either extend themselves or be replaced by machines or something. That's very probable. And once again, it may not happen in 20 years like some people predict. It may happen in 200 years. But I think it's pretty clear that there's a finite number of things to add to a computer before it's as good as a human. And as good does not mean exactly the same as a human. It means that, well, yeah.
Like a submarine swim, that kind of thing.
Yeah, things like that. But then the problem is that when computers become agents, then it's the computer the agent, not the human. The human will end up being a zoo, and the computers will end up conquering the galaxy and further. But yeah, they will still be our descendants. Or maybe not, but I think there's a lot of evolution ahead of us, under one way or the other. Yes, Jimmy.
Okay, so there's, I think, Eugene Wigner. No, not Eugene. I can't remember his name. Anyway, there's a theoretical computer scientist who claims that interaction machines are actually super Turing, but they aren't. Because they don't, since like an operating system is designed not to terminate, that it can't be like strictly algorithmic formalisms. And I'm just curious, since you talked about interaction as being important for the future of software development, are you concerned about it?
Yeah, this is an old debate. There are, of course, people who are saying that, but even in the 80s, there's a great book, Understanding Computers and Cognition, by, I don't remember, a Chilean guy and an MIT guy. Flores and I don't remember the name of the MIT guy, big shot MIT guy. And it was basically saying, oh, AI does not work precisely because machines are not embedded in the world or whatever. It's the Heideggerian approach where either you're in interaction with the world or you're not. And then after this book was published and showed indeed limitations to all the approaches so far of AI, well, AI researchers say, hey, how can we embed machine in the world? And yes, you can have a machine interaction with the world. Just because the core of the machine is algorithmic doesn't mean it cannot be in interaction with the world. It's just the way you plug the I/O on the machine if you want. So I think this argument is ultimately specious. Yes, if your machine has no I/O, it's not alive. Duh. But if the machine does have I/O and feedback loop with the outside world, it does not matter that much that it is algorithmic at its core. And it is 45. We have 10 more minutes, maybe. Yes, Jimmy.
One more question?
Yes.
So since Tunes is kind of vaporware?
Oh yes, it's the greatest vaporware in the world. If you haven't read Tunes, there's a Tunes mailing list from the 1996 and on. It's like the greatest vaporware in the world. I learned so much with partaking in this vaporware.
Then what would you give as an example of something furthest on this hierarchy, furthest along this development of better stories as an actual example of approaching evolutionary software?
Well,
if there is any.
Yes, I think thinking in terms of well, I have a talk about reflection and semantics, and I also have another talk on platforms versus applications. When you understand that if you write software in terms of platform as in Emacs or even .NET or something like that, instead of thinking in terms of applications, then you can multiply the work and the effect that a coder has, because his code can be used by plenty and plenty of other software. Whereas if everyone writes his application, everyone has to rewrite all the stupid and dumb and boring parts of the applications all the time. Like, there's so much redundancy in the kind of code that people write today. So you can have better organizations that make much better use of human resources or computer resources, and that will eventually, I think, survive and overtake the old world. But you have to work in the right direction. And yes, the transitions are not, oh, it's better and everyone goes there. No, the transitions take time, and it also takes effort, and it takes genius and people doing the right thing. So once again, evolution does not happen without you. It happens through you. You are not the victim of evolution. You are the actor. So do your thing. Something else that I like, I'm a big proponent for sort of orthogonal persistence. Orthogonal persistence is the idea that instead of having everyone write save and save all the time, or else your thing goes away when you turn off the computer. And even if you save on the computer is broken, but you don't have a remote backup and fail to do the remote backup manually, so it's still lost. So instead of thinking in terms of explicitly saving, you think in terms of, the system should do it for me. Just like when you write something to a register, you don't explicitly spill it from your registers to your L1 cache, to your L2 cache, or L3 cache, to your RAM, and then to swap space. The computer does it for you. You never have to worry whether a particular variable right now is in a register or in swap space. You just use it, and the computer does the right thing. Why should you explicitly save a file and tell the computer when to save the file? If I type the thing on the computer, I mean it to stay. If I didn't care for it to stay, I wouldn't have typed it. So everything you type should be persisting by default, and I think that's a very important paradigm. And when you understand all the consequences of this paradigm, then it changes also the way you write software. Like, I think IBM once made a study that 30% of the software was just for saving and restoring data. And I suppose the number is still true if you take into account things like marshalling and unmarshalling data to send it across the network. Like 30% of your code is just dealing with network connections and JSON and crap like that. That's a huge number. Imagine that overnight, from 30% it's become like 3%. Like, it's like plus 27% in productivity, or no, I don't know how to do my divisions by well, order of magnitude 30% of productivity additional for everyone. That's a huge boost. It's as if people have self-driving cars, and then they have like 2 hours more in their life than they don't have right now. It's like huge productivity boost. So yes, I think there are lots of productivity boosts that are there for the taking if we recognize that they are, and if we work for them. And that's part of evolution. Like, you recognize the opportunity and you work for it, and you make it happen. And yes, but you have to step back and look at the picture. If you only look at your daily bugs, you will not find what to work on. You will just find, oh yes, let's work on the next bug, the next feature. You have to step back at some point. You don't have to step back all the time, like I do. That's crazy. But you still have to step back every week or every month and, hey, am I doing the right direction? Am I taking advantage of the big opportunity, or am I just like grazing the grass like everyone else and being eaten by the alligator or whatever, like all those gnus? Yeah, you have to step back at some point and decide what you are going to work on and what's the big change I want to be part of, and not just more boring code. Okay, let's write it in Haskell rather than Java. But you know, it's still a small progress, but there are bigger progresses that you could be part of if you dare to do it. And you're not stupider than other people who do big progress. And sometimes there's a saying by Alan Kay, like the good point of view is worth 90 points of IQ. And I think he's right. Like if you look at the problem the right way and the others don't, you've got a head start. And of course, if you're intelligent and you have the right point of view, you can go even further. But like guys like Edward Kmet, I think, I don't know if you are Haskellers, but this guy has a point of view. Let's take Haskell. Haskell is good at category theory, so let's make every program the most general possible for category theory and go for it. And he ran with this idea, and he's already bright, and he made it happen. He single-handedly changed the shape of Haskell. You could do that if you have the right point of view and you're not stupid, and you can change the world. Yes?
Any advice for the young? How would you change education to make this more?
Advice for the young. Yes, I was young and stupid myself once too. Your days are shorter than you expect, but compounded interest works better than you expect to. So yes, go for this long-term vision, because if you keep going this way year after year, you will make a great change. A guy I like very much is Matthias Verleisen. He had this vision on using Scheme and improving it and doing things with it. And if you look at where he was at like 30 years ago when he started PLT Scheme, it sucked. It was one of the worst schemes on the planet. But he kept improving it. He had this vision. He kept adding to it and convincing students to work with him and partake in his vision. And now PLT Scheme, or now called Racket, is by far the best scheme on the planet in so many different dimensions, and the best programming language in many dimensions also. So, and that's compounded interest. That's just keep working at it and go for it. So yes, it's a vision. It's the adding to it. And if you're young, well, you have like maybe 10 or 20 more years of compounded interest than I have, because I am starting old at writing the code. I mean, whatever. I mean, so yes, the power of compounded interest. Of course, the usual thing like yes, learn from the best, read the code, whatever call it. Do your homework. I mean, the other thing I will tell will be probably the same as everyone else. So don't know what else to say that's original. But yes, find where you can be original. Find where you can add something in the right direction where no one else is adding. Because, for instance, when I went to École Normale Supérieure, it's a school full of very brilliant people. Before I went there, I thought I was like top of the heap or something close to it. And then I was there, I found that, I was at the bottom of the heap. But I found also that in mathematics, I was totally at the bottom of the heap. But in computer science, I was slightly above the bottom of the heap. So I switched from mathematics to computer science very quick. I understood, or I saw that as physics, I would be below the bottom of the heap. So find what you're good at and do that, and do more of it and more of it. But also take into account the rest of the universe, because you're in a contextual evolution. So find your niche. Make sure that's a niche and not just a desert. Like find your niche and go for it. Yeah. Still one last question. Okay. Well, there's a paper associated to this talk that has a bit more to it than the talk itself. I have a talk on Saturday about better stories for better software, where I do not touch at all these stories. It's a totally different set of stories. I have a blog, ngnghm.github.io. ngnghm, do I have it somewhere? Anyway, if you look at this page, this GitHub page, it has links to everything. So there. Well, thank you very much for coming to this talk, and hope you enjoyed it.